Imagine teaching a robot to follow your instructions, not just go to the red room, but go to the red room and eventually push the box into the green room. That's where temporal logic comes in, a precise language for describing time-dependent behavior. But here's the problem: humans speak naturally, while robots need formal logic. Translating natural language into temporal logic has been tough. Existing methods rely on large language models, predicting one token at a time from a massive vocabulary, like choosing the right word from a dictionary of 100,000 options. It's inefficient, error-prone, and struggles with references, like the box, meaning the same object later in the sentence. Enter grammar-force translation, or GraFT, a smarter way to bridge the gap. GraFT cuts the noise by restricting the model's choices at every step. First, it uses a masked language model, like BERT, to identify key elements in the sentence. Instead of guessing words, it labels each part as not an atomic predicate or part of AP1, AP2, etc. This turns a complex task into a simple integer prediction, reducing the output space from 100,000 to just 6 options. Then, for the actual translation into temporal logic, GraFT uses a sequence-to-sequence model, like T5, but with a twist. It enforces the grammar of temporal logic at every step. Before each prediction, it checks what tokens can legally come next. If a not sign, not can't follow a always, the model is forced to skip it by setting its score to negative infinity. This isn't just a trick, it's mathematically sound. By eliminating invalid options, GraFT reduces the cross-entropy loss and focuses gradients only on meaningful paths. Less noise, faster learning, better generalization. In tests, GraFT outperforms state-of-the-art models by 5.49% on average in end-to-end translation, and by 14.06% on out-of-domain tasks. It works even with small datasets, thanks to smarter constraints. The result? A robust, efficient, and scalable system that turns natural language into precise, executable logic, making robots truly understand us. GraFT isn't just better, it's smarter. And that's the future of human-robot communication.